A Short History of Nearly Everything. Book written by Bill Bryson. Part 3. A New Age Dawns. We have a lot to cover, so let's get started. Because this is a short history of nearly everything, we're going to jump around a bit, so try and keep up. Chapter 8. Einstein's Universe. Luminiferous ether is an imaginary substance that electromagnetic waves travel through. It was needed to explain how light moves through the emptiness of space. Max Planck was the first quantum physicist. You probably know the guy after him a lot better, though. Albert Einstein was a German-born theoretical physicist, or a quantum physicist. He developed the theory of relativity, one of the two pillars of modern physics. Albert Einstein's equation E equals mc squared is energy, mass, and the speed of light, c squared. Mass and energy have an equivalence. Einstein's theory of relativity is quite intriguing. For example, if you had a train traveling at 60% of the speed of light, if there was a person outside of the train watching it, they would see the train pass by at 60% light speed. The person inside the train would see that person who is watching go by at 60% light speed and going in the opposite direction. That person on the outside would be relative to the person on the inside of the train, and vice versa. Space-time is an interesting theory. It's like a sheet of rubber. It stretches and it can sag. This is the effect that the sun and a black hole have on space-time. These two women were inspirations to science, and this is what they contributed. Henrietta Swan Leavitt found a way to measure the brightness of the stars. And Annie Jump Cannon devised a system of stellar classifications. Chapter 9. The Mighty Atom. We are billions of years old. I mean, I'm only 15, but my atoms are billions of years old. They just keep getting recycled and recycled over and over again. Pretty cool, right? John Dalton is known to be the father of the atomic theory. He was able to consider the relative sizes and characteristics of the atoms and how they fit together. Ernest Rutherford on the left and Hans Greer on the right did an experiment with ionized helium that taught them a little bit about the structure of the atom. Some of the atoms bounced back, but it wasn't supposed to happen, like a bullet shooting a paper, but bouncing back. The Heisenberg uncertainty principle was uncertain because we can't know for sure the path the electron takes as it moves through space. Chapter 10. Getting the lead out. Lead poisoning can be a serious condition. It can damage the brain, damage central nervous systems, cause blindness, insomnia, hearing loss, cancer, and pretty much just everything bad. CFCs are so harmful to Earth because they destroy the ozone layer in the stratosphere. Thomas Migley did dangerous experiments. The most dangerous of them, however, was the CFC because it had an impact on the ozone, therefore making it more likely for the Earth to be killed. So don't be Thomas. Save the Earth. Carbon-14 dating had some issues. It could easily be contaminated from carbon contained from other sources, so it wasn't always completely reliable. You can tell the age of the Earth by using meteorites. Patterson liked using space rocks because meteorites are practically leftovers of the Big Bang, and would therefore be around the same age as the Earth. The ice in Greenland can help us determine how the concentration of the atmospheric lead has changed. Each year there is an annual layer of snow, and therefore we can look back at the snow to discover the layers of lead. Leaded gasoline and CFCs are banned in the United States, but the threats are not over, because lead lasts for a very long time, and even today people have 625 more times lead in their body than a century ago. Chapter 11. Muster-marked quarks. Scientists hold neutrinos in tanks filled with 12.5 million gallons of water that have a relative abundance of deuterium in it. Neutrinos are particles sent from the sun, and they are so hard to trap because they pass right through the planet and everything on it, kinda like they were never there in the first place. The Earth moves. The Earth has tectonic plates that move over time and shift. At first, all of the continents were stuck together. It was called Pangea. But over time, with all the Earth movements and the tectonic plates sliding, it moved apart and became the continents we know today. Did you know that the highest mountain range is actually underwater? Pretty cool, huh? We know more about outer space than we do about our own oceans. There's so many mysteries hiding underneath the blue water. Earth is unique because it's the only planet that we know of that has plate tectonics. Alfred Wegener made many contributions to the discovery of the tectonic plates and how they move. However, he didn't get to bask in the glory of everybody noticing his ideas because he died. But, I mean, that's kind of unfortunate, if you think about it. Unfortunately, that's about it for part 3. You can see more of my videos on my YouTube channel, or the links down in the description. Thanks for watching, and I hope you enjoyed.